Welcome to the prototype presentation of the FlipForte project by Group 10. The main objectives of this project are to develop an application that is user-friendly and allows the user to have access to a personal library of saved digital sheet music. The application will also feature an option to record and playback audio and an option to write notes and annotations directly on the sheet music, which can be saved after. And our last objective is to allow users to turn the page using an ASU. Most of the objectives have been realized since the beginning of our project, such as the user interface, account creation, secure login and logout processes, saving PDFs to a library to be viewed and edited later, and finally audio recording and playback have all been achieved. There are a few remaining challenges. We still need to enable editing the digital sheet music in PDF formatting and save those edited PDFs to the personal library. We also need to determine a method of configuring our touchscreen with the Raspberry Pi, as currently the OS does not acknowledge touch as a viable input in order to work as the primary display for the Pi. And lastly, we need to design and create 3D prints for the housing for all of our hardware units. One of the proposed changes for the design and implementation of the project is the reduction of ASUs from 2 to 1. This is to make the units more accessible and easy to use for musicians of all types, without the need to change the way they are used for different instruments such as piano, which is an instrument that needs to use a foot in order to play properly, or violin, which does not. We have also changed the method for storing any saved files. Originally, our design indicated the use of the AWS S3 storage system, which we changed to an API that will allow interactions with the database and the server.
My name is Berndrew, and I was primarily involved with developing the web architecture and data communications methods for our ED2 project as follows. First, I was in charge of ensuring that our data communications were secure, both so that our users' security was not jeopardized and so that our infrastructure would not be compromised. There were many parts to this, including taking steps to secure our database, configuring TLS encryption on data being sent between the client and the server, and reviewing all client code regularly to ensure that no malicious functionality could be injected. Second, I developed an API that allowed other components of the project, such as the app and the ASU, to remotely send and receive data. This involves everything from getting signals from the ASU to impact the rest of the system, to storing user files so that they are easily retrievable and integrate seamlessly with our custom PDF reader and the mobile app. Third, I developed our custom PDF reader. Until recently, we relied on a pre-made PDF reader to display user files, but it didn't have the functionality that we required, including remote page turning without having to reload all the resources, the ability to implement user annotations in notes, and single-page view focus. Therefore, I built a custom PDF viewer that exposes this functionality to us and allows us to add features, change styling, integrate subsystems as we see fit. As of right now, the custom reader fits our requirements aside from allowing PDF editing. Thank you.
Over here we have a search screen, and I can look at PDF files that are stored with that account information. So if I click on this first PDF file, I can see these 2 pages of this PDF file. If I want to view another one, I can click on this PDF file, and I can scroll through this PDF file. I can zoom in, I can zoom out, and I can also tap this button at the top right, where I can download this PDF file directly to my device, or I can send it to my printer if I want to print out this PDF file. We also have this record button, where if I tap on this button, I can do some sort of recording. If I click this stop button, I'll have a notification that gets displayed on my device saying that the recording has saved to my device. If I click on this library button, I can see those 2 PDF files, but it's in this nice layout. If we go back to our downloads folder, which I shall be navigating to right now, I'll click on downloads, and I can see this top MP3 file that is associated with the recording that I just made in this demonstration.
Hello, my name is Yang Feng. I am presenting the ARPU, or Audio Recorder and Playback Unit. This is responsible for recording, storing, and playback of any music or sound that the user wishes to record. It consists of a USB microphone to record the music or sound with, a Raspberry Pi as the main processing unit, and space for the local storage for the sound files, and a 2-watt speaker for the playback of the sound files from the Raspberry Pi via the 3.5mm AV jack on the Pi. For now, we will use a pre-made powered and amplified speaker I have on hand. Testing, 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 testing. Testing, 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 testing. However, the amplification circuit for the final project is being assembled. This circuit consists of the LM1877IC dual audio power amplifier to provide audio amplification for stereo sound. Thank you.
Hello, my name is Heather Crawford. I'm demonstrating the ASU, our accelerometer sensor unit, which picks up specific movements and sends these movements as commands to the FlipForte application. When I move my foot, it will turn the page. Keep in mind that any latency is due to the fact that this is running on an emulator and will be much faster when the application is running properly. To turn the page, Mo or the user must first enable the ASU in the application. I will demonstrate a couple ways to move my foot to make this work. If I move too fast, then a enhanced delay that doesn't allow me to turn the page too quickly to avoid false positives will kick in, as happened here. So I just need to go it again. See, when I'm done, it is again disabled in the app. The ASU is made up of only a WeMOS chip and an accelerometer. This fulfills nearly all of the functionality requirements and will be approved upon rapidly. Thank you.